T-shirt. Yeah. This is the last year T-shirt.
Okay, thank you, man. So, let me, give you a small story behind this topic. This is like one of the favorite topics of mine.
Oh, sorry. 2 minutes left. Okay. We will. Yeah, just timing that is. Yeah, 2 minutes later, so we will begin. So sorry about that. Yeah. Sorry.
So the story is
okay.
I can maybe give the story a little bigger so that we can cover like this.
Okay, of course.
Yeah. Okay. So I was actually, reviewing doing the code analysis of one of the internal projects, and when I asked the developer that, hey, I'm seeing like you're using lots of third-party components as part of your project. So where do you use it? And he responded saying that it's open source, right? So we can use it. I was like, okay, that's correct. It's open source, you can use it. But have you actually checked that how many third-party, libraries or the component actually got installed as part of this project? Then he started like thinking, right? Because he didn't have any clue that how many third-party components actually added as part of his actual package, what he added in the project, right? So this is why I'm here, and I'm going to talk about why build supply chain management and how it is going to help us as a developer and where it is going to help us in the long run, right? So the software. Yeah, and before that, let me introduce myself. I'm Vijay. I have been working in the security domain for quite a long time, and currently I'm working as a lead security engineer at Observe. So let's first understand what is actually the software supply chain, right? So in simple language, if you see what is software supply chain, it's actually the ecosystem of the software, or you can say the component, the third-party libraries which we are using, or the most important part is the developer who is actually writing the code, right? And they are the maintainer of the application. They are actually writing the code. They are doing all of their stuff. So they are also part of the supply chain. And obviously, developer plays a fundamental and key role in the application development as well as in the security of the application, right? And you see that today, more than 90% of the code actually is coming from the open source in your complete project, right? And that's a huge. But why developer do it? Because it's open source and developer want to deliver fast. So the open source is readily available. You can go, you can use the open source and deliver it fast. Why? Because you have customer commitment, right? You can't miss. You have deadline to ship, right? So this is very, very important that we end up using open source because there are like so many different reasons of it, right? So what you do as a developer, you go, you do npm install, and let's say you are asking for one package, you get it. But what you are not asking for, but you are getting as part of the package is this one, right? So you are getting this, and you think that okay, this is the package what I'm getting as part of the actual package, but actually it looks like this, right? So you're installing one package, and you're getting so many hundreds of different packages as part of it, right? And you don't know that the dependencies, which package, let's say your package has some dependency, and then your package has dependency of dependency, which is very crucial, right? And you don't know whether this particular dependency, which is like the end dependencies, it has some vulnerability or not. You don't even know, right? Because we are not going to check each of these the dependencies whether it is fine to use or not. So to quick show, if you see CNC.js is a small library. When you install this, it installs almost 722 packets. That's huge, right? So you are going to add 722 packets as part of your application and as a component in your complete software cycle, and you don't know like which of 722 packets has vulnerability and which not, right? So quick of this, let's say, then by the way, how many of you use an npm ls command to see what the tree look like for the third party? Yeah, that's like a good way to see that what is the third party library which you are using in your application and how it is look like, right? So I'm saying it's not coming, but yeah. Let's run this command and see what's happening. So if you go up, you see I install a super agent, which is actual, the library which I want to install. And these are the direct dependencies of it, right? So you have component emitter and then the second one. However, I just asked to install this particular library, right? But it got as part of my package, right? And this particular library is called the transient dependency. So it's like dependencies of the dependency. So if tomorrow you get some vulnerability in this particular, let's say, dependency, it's very difficult for you to see how you're going to fix it, right? So let's go back into our slide. And at the end, if you see your complete application, right, you see more than 90% of your code is actually coming from open source. So it looks like this, right? So you see everything is open source, and there is a very small portion of it is actually your own code, what you have written, right? So this is the problem, right? Because there are so many open source added in your product that you don't have a clue that okay, what is going to get something malicious or something bad into my product. And let's just say that if you are installing an npm package, then you're going to trust 79 third-party package and 39 maintainers of those packages. It means you are trusting all of them, right? And that's what you're adding in your software, right? So the question to you is, who do we trust, right? Are you going to trust the third-party libraries, which is part of your application, or the maintainer of those libraries, right? And that's really important. So we understood what is the software supply chain is look like. Now let's understand what is the attack, right? Because this is also very important to understand that from where the attack can come, right, in your complete software. So usually we say that if I'm using a vulnerable component, let's say I'm using an npm package, and there is some vulnerability in the npm package, then that can impact my software and my software can get compromised. But it's not only the npm package and the dependency of npm package, it's more than that, right? So it can come from, let's say, malicious code injection. It can come from the dependency confusion attack, or maybe the third-party component which you are using as part of your software. So there's a nice framework called SALSA. It's supply chain level of software artifacts. It actually helps us to understand that where is the gap or problem in my complete supply chain, right? And it is actually, it's in very early stage, but organizations like Google and other big giants, they are actually helping us to build this so that we have a guideline to see where is the problem and what and how we can secure the complete supply chain. So let's see from where the attack can happen, right? So you see here you're writing code, you're a developer, you are using some kind of source, a CM. Then you have build, obviously, because this is how the software build cycle is look like. And then you are getting a package, maybe some npm package out of your build, and then you have some dependency, right? Let's say you are running bad code. There is some problem, or the code is actually bad, and you might get attacked from that place because these are the connection points, right? Or you can say the entry points in your complete software cycle. Or it can come from, let's say, somebody modified the code in your team, and you don't know. Let's say you are not aware that what actually he added. It can come from there, right? Or you have compromised build platform from where you can get the supply chain attack, and there are like a lot more. Now, in organization, we see that the source threat, which is the developer and let's say your laptop, your machines, it is come as a source threat, and then you have a build threat. right? Where your actually code is getting compiled and you are getting a package out of it. Organization have security team, have CISO, so they are able to deal with source threat as well as the build threat, but they are not able to deal, or let's say they are not able to handle is this particular part, right? The dependency, because that's not your code. It's coming from the third party. It's coming from somewhere else which you have not written the code. And you can't control it because if you're using a third party library and if the third party library has vulnerability, it will automatically add it in your product, right? It automatically gets added in your software, right? So that's a huge problem, right? Now, we have seen what is the supply chain, what is the supply chain attack look like. Let's understand why supply chain attack is critical in today's era, right? So we'll go through some of the examples of supply chain and we'll see that, at what extent this attack can happen. So there is very famous, vulnerability came in 2021, Log4j. I think you must have heard of it. So Log4j is actually a logging framework used in Java application. It's a logger, so you don't have to write your own logger. What you can do is you can go and use this to record any error messages or user input in your application, right? So what was the vulnerability? Vulnerability was that it is called as log4 shell, and the vulnerability was that how log4j, the older version of log4j, actually handles the JNDI, right? So JNDI is actually Java naming and directory interface. It's an API which tells your application that okay, go and fetch some specific file or script from the remote server. So what attacker did is, let's say you host your own LDAP server where you added or you created your own malware. You do call to the LDAP server, get the file and execute it. There is no authentication. There was no authentication. And the older version of Log4j was not able to handle or see whether the file which got downloaded in the application is actually vulnerable or not, or it is malicious or not, right? So this was the the vulnerability, and it was so widely spread, used across the world that it was categorized as a catastrophic security vulnerability of the era. And I think still we talk about it. So what was the impact? Impact was huge because people are not knowing how to fix it. It was categorized as zero-day vulnerability. It means no patch available, right? It was so widely used that it is also categorized as the remote code execution vulnerability because attacker don't have to come here and do this. They can execute the command from anywhere in the world. And it was so straightforward that they don't need any special permission to run this particular vulnerability. So it's like so easy to use. Like you can go just host your own malware and just put the the NDI lookup command and get the file done. So it is that simple. The other one is polyfill vulnerability. It came in this year, 2024, February, Feb 2024. I think you must have heard of it. So what the polyfill? Polyfill is actually an open source, obviously JavaScript library, which add modern functionality to the old browsers, right? So you can use this and you will get the modern functionality. So Andrew, who was actually the maintainer of this particular package, so what he did, he tweeted about this particular package, saying that today's almost all the major browser has this the adoption of this new functionality, and we should not use it because from where the script is actually getting downloaded, right? That place you are actually creating a huge risk for the organization who is actually trusting on these kind of third-party libraries. And what happened to this? After this, we are seeing that the attack happened. So how it happened? Let's see. Let's say you have application and you have defined an environment saying that it requires polyfill, and we say that okay, I don't want to use it. So you're safe, no problem. But let's say you want to use it, right? Then what will happen? It will load the polyfill, and before this, the attack, what attacker did is he actually modified this JS file, which was getting from cdn.polyfill.io, right? And he was able to get this particular file modified, and there was some malicious thing added in this polyfill.js file. So as soon as your application load polyfill.js, it started downloading the malicious code, right? Because this file had the malicious code. And as an owner of the organization, or let's say you are maintaining the application, you don't even notice that something got changed because you have not changed anything in the application. You are just loading, the polyfill as it is, and then it will execute it in your app. And what will happen? Instead of going to some legitimate site which you have requested, you will start going to some malicious site, right, or some spam site. So this what happened, and it was also widely used. So immediately after a while, what happened is Google, Cloudflare, and other big organizations, they came forward and they started flagging this. So you might have seen this kind of error. If you might have noticed in I think April or May during that time, it got flagged by the Google. So it's Chrome browser, the error which I got. And if you go deep into it, you see that there is a signing base, and it's actually the source is polyfilter type, and it's taking data from your CDN or polyfilter. Again, Andrew, tweeted saying that hey, if you are using polyfilter, you should remove it immediately because he never owned the site, right? He never owned the domain from where it was actually downloading the script, right? It means the cdn.polyfill.io, he never owned it. So what happened is anybody who owns this can go and change the file, and your application is automatically vulnerable. Right? It was that simple, right? Before this, and then it got mitigated. And again, we have seen even Google, email to his customer saying that polyfill.io is actually affecting websites. So if you are using, you should stop it. Now, what was the impact? Impact was huge again because it was used by more than 100K plus websites across the world, and everybody got impacted because everybody was using this and trusting this particular library. And what we have seen is not only this particular library, even some of the domains also got impacted by this. So you see obviously the cdn.polyfill.io, bootcdn.net, and a couple more. And some additional indicator of compromise was also observed after the analysis of the logs. So you will notice that this is not Google Analytics, right? It's Google Analytics. But what happened is when you do a code, let's say when do your log analysis, you go very quickly. Okay, there's no problem. Let's say if something happened to your app, what you do is you go and see the logs. You see the log, you say, okay, no problem because this is coming from Google Analytics. I'm good. But if you don't notice, you will obviously going to skip it because that is how attacker is trying to use your ID, right? So he wants to skip. He don't want to be noticed. So that's why he thinks like this. The JS file is coming from Google Analytics rather than Google Analytics. So this is how actually the attacker is trying to trick the person or the maintainer who is actually doing the reviews. Another very famous one, I'm sure you must have used your parser, right? No? Then let's see who haven't used it. It's another JavaScript popular library, which is used to detect a browser and which is the OS CPU and other things from the user agent. Okay, it is maintained for 15 years. You will use it. Okay, let's see. It has more than 13 million weekly downloads. Now you will use it, right? You will not think about it. It is used by millions, including Google, Amazon, Facebook. So even though you say that, hey, I'm not using it, you're using it anyways, right? So it's indirect. But what happened before, like 5th October 2021, everything was fine, and the maintainer of this particular package, the core maintainer named Faisal, everything was fine with him, nothing happened. But on 5th of October, it was noticed that it was under sale. And if you read it, it says that I sell a development account on npmjs.com, and it more than 7 million installations every day. So it was like in past 20 months. and there is no 2FA to the account. It means his account is already unhacked, right? So the maintainer account got hacked, and the Russian attacker actually hacked his account, and what he did, so Hazel noticed that okay, something happened to his, and the attacker published 3 different versions of the UFR. Interestingly, these all released very quickly. So even if your application, let's say in auto update mode, it will automatically install a new version and you will get. And if you see this carefully, so there is something called hdb.dll. This file is get created as soon as it gets updated, and there is some malware or some malicious code will get added to your application, and what will happen is amazing, right? So it can steal your password. It can read the browser history, right? So it can do crypto mining. It can do even account takeover as well as the system takeover. So it can do a lot, right? So it was so easy, and for the attacker who actually did this, it was very hard. If your application is in auto update mode, it's very difficult for you to keep track of it, or make sure that you are not impacted by this. Another example, we have seen that how good packages become bad when it go into the attacker's hands. But this is something interesting, right? There is no attacker in this scenario. There is actually the maintainer of this particular package called node.js. So let's see. Brendan is also a nice person. He actually maintains 42 packets. If you see, this is a recent screenshot what I have taken. And there is a big famous package called node.js, which is actually maintained by Brendan. What he did, again, this is maintained for 10 plus years, so you will not think using any such package. It has good downloads. What he did is he actually added a 1 line of code, just 1 line of code. And it was so obscured that you will not be able to read it, what is there. So if you convert it into base 64, you will see that what he added is actually trying to find, he added a IP geolocation. So he's trying to find that from where the system is actually using this, right? And if you convert it more, you will see that he added some more things as part of the code. What is the country? What is it is Russia or Belarus? And what was the impact? Impact was delete, 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 right? So what it does is it tries to find whether you are using his API, and let's say if your location is belongs to Russia or Belarus, it will do delete, 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 delete the parent directory, right? Delete the grandparent directory, delete the root. It means your system is cleaned up, right? And it did message in GitHub saying that it is open source, documented, and you have it's open source license. And if you have downloaded my software, I'm allowed to wipe your computer. So now see if somebody who have used it and visited Russia and try to find that okay, you are in any of these locations, you are done, right? So this will happen. So what we have seen is the supply chain attack is actually a very critical problem today, right? And since 2017, we have seen that more than 700k plus malicious component is already detected, and we have seen all of these examples. So what we can do is so this is a reference which we can see Sonatype, and all the history of the supply chain attack since 2017 is actually maintained here. So if you want, you can go through this. This is nice resource. Okay, so whenever you are using any kind of third-party libraries, you should review. Obviously, you can't review the complete code, but you should at least review the important things of it, whether it is not, it is going to impact your application at any point of time or not. Right? It's very, very important. Now, because we have seen the supply chain attack is critical, it can impact you at any point of time. Now, we need to understand that how we can manage this. So, supply chain risk management process actually help us to see that how we are going to manage the supply chain, vulnerability which might come in the system. So there is a nice flow which was given by NIST. So what it does is it's actually help you to create a flow as an organization to have a good a nice view that how you are going to manage any kind of supply chain attack if it happens, right? So what you can do is you can create a business process or the key is what is the key required. You can maintain the inventory of the software licenses what you are using. You can check whether the supply has actually license support or not. You can analyze the key rule in your complete software, and then if there is any vulnerability coming, how you are going to disclose the vulnerability, right? So I'm showing you about some details about how we can manage and maintain the inventory of the software, and there is something called SWOM. It's one of the a good way to understand the software bill of material. So bill of material is from a long time, right? So you drink, let's say some software, and then you see that there are ingredients in it. So you can understand in the same way that software bill of material is nothing but it's the component and it's the inventory of all the component what is being used in your software. So it's not the normal inventory. It has like the license, the version, the dependency of dependency what you're using, and a couple more things, right? Now, SBOM can help you to deal with supply chain risk management. And where it can help is, you can deal the vulnerability proactively, right? You can enhance, as an organization, you will get enhanced visibility and transparency on usage of the software, the third party, right, which is part of your application. Obviously, it is going to help in the risk reduction of your complete supply chain attack. It will help you to manage the license, and there are like a couple more. It will help you to see whether actually the library is coming from the legitimate source or not, and obviously it can help you to take the decisions, right? So there are a couple of ways to create a SBOM. You can create in different ways, and these are like some of the famous ways through which we can create the SBOM. So and show you how we can create in Cyclone DX. It's actually a flagship of OS, and because this is security, so I'll use the Cyclone DX. So let me show you a quick demo because we have seen this super agent. Now let's see how we can create a simple and nice the SBOM of this particular project. So if you hit enter, if you see here, this is Cyclone DX npm, and by the way, I'm using this npm package. You can follow. It has like the documentation. I'm using the same npm docs to actually create this SBOM of my actual the library what I have shown. So if you hit enter, you will see that it is going to create the SBOM. And let's go up. Yeah, and you see here it has all the libraries and everything what you have used. So let's go. What we want to say is, so this is the library what I'm using. This is the name of the library. This is the version. This is the reference. And the interesting part is the component, right? So you see, here's a component, right? This is what I'm using. I'm using a library called superagent. Version of it. Who is the main author of this particular library? What is the description? And the important is the license, whether it is GPL, MIT, or whatever. You will get everything here. And not only this, we have seen that we have dependency of dependency. So you will be able to see that what is the problem in the dependency of dependency. So let's see if you go and here already checking the authenticity. SHA-512, it's checking whether it is coming from the authentic source or not. And then you see here Debug is both the direct library, direct dependency, MS, right? So MS was indirect dependencies of this, and that also added here, and you will have all the details of this particular library, what is actually added in your product. So it means that if you create an S-form, you will have very good understanding of all these components which is part of your software, right? And it will help you to obviously understand that, let's say tomorrow you see that there is some vulnerability came in one of the dependency, you don't have to go here and there. You can go to the response, check this is the version, this is the vulnerability. If it is impacted, then you need to fix it. If not, then it's good, right? So you don't have to take time to even think and see that, okay, from where this particular library is coming, what is the version, whether I'm impacted, not impacted. You can go check the response and quickly you can solve the problem, right? So this is fast, and this is actually an easy way to see how we can manage the complete supply chain security, right? And really interesting one. So let's see the takeaways, what you have learned till now. We have learned about what is supply chain, what is software supply chain. What is the supply chain attack look like for us? Why supply chain attack is critical, right? That's very important to understand, because as a developer, we end up saying that, okay, use this library and you are done. It's not done, right? You need to think twice before using any third-party library, whether that is good to use, okay to use or not. It's very, very important. Then we have seen some of the examples from past, like polyfill answer was an interesting one. We have also learned about how the risk management process for any organization is look like and how we can create it. And lastly, we have learned about SBOM and how it is helping in the complete supply chain security, right? These are the some of the references you can go through, and some interesting ones. You will learn something more, obviously. And you are awesome, right? With this, my first internet talk is delivered, and I'm super excited. Thank you for listening. Thank you for having me here. Thank you so much.